we are starting with the next unit, that is 11th unit of the 11th class, that is P block elements. This is our lecture number 1. Question 1 is write electronic configuration of boron family. This is group number 13. So we have the different members of boron family. We will be learning like this. Valga inter. Boron is 5, it is 13, it is 31, it is 49, and then we have 81. Configuration is helium 2s2 2p1, it is neon 3s2 3p1, then we have argon 3d10 4s2 4p1, then we have krypton 36 4d10 5s2 5p1, then we have xenon, that is 4f14 5d10 6s2 6p1. So they have general electronic configuration of ns2 np1. Then we have second question of boron family. Why ionization energy of 13th group is less than group 2 elements? Reason for this is their outermost electron, the most loosely bound electron, is present in the p subcell, which is loosely held by the nucleus. Therefore, they require less energy for loss of this electron. But in this case, the general configuration is ns2. Here it was ns2 np1. So last electron is to be removed from p subcell. But in this case, that has to be removed from s subcell. Since p subcell is lying away from the nucleus, penetration effect of the p subcell is less. Therefore, it is easy to remove electron from this configuration, and the ionization energy of 13th group, that will be less than that of group 2 element, because their electron is present in S subcell, valence F subcell, which is completely filled in this case. Then we have why boron does not form tri-positive ion. B 3 positive ions are not formed. Answer: it is due to high sum of first 3 ionization energy in case of boron. It cannot lose all the 3 valence electrons easily, so does not form B 3 positive ions. Loss of electron, all these 3 electron, valence electron, is not easy process, because that require large amount of energy for loss of electron. That's why boron family does not show this oxidation state. Then we have question number 4. Comment upon oxidation state of members of boron family. Boron shows +3 by sharing electron with electronegative atoms. Aluminium can show +1 plus 2 in the gaseous state, plus 3 in the solid state, while gallium, indium and thallium prefer to show plus 1 state due to inert s pair effect. They do not lose s electrons easily. They lose p electron more readily as compared to s electron. That's why they prefer to show plus 1 state. They do not show plus 3 state. Then what is inert s pair effect? This is very important question. It can be answered from the electronic configuration. If you see the electronic configuration of the lower elements, where d subcell and up subcell they are participating, so the shielding effect of these subcells is very less. D subcell and D subcell, F subcell and D subcell, shielding effect of these subcells is very less. So they do not shield the outer electron from the nuclear pull. The result is the valence electron, they are held more strongly by the nucleus, so their loss that becomes difficult. So we'll be now defining what is inert s pair effect. So it is the tendency on the part of valence s electron not to participate in the reaction. Why they don't participate in the reaction? It is mainly because of the poor shielding effect of the D subcell and F subcell. They do not shield the new outer electron from the nuclear pull. Therefore, the outer electron they are held more strongly by the nucleus. That's why their loss becomes difficult. This is called as inert s pair effect. Then we have what is the common trend in the melting and boiling point. In boron family, boron has high melting and boiling point. It is due to covalent network. Due to its small size, it has the capability to form the covalent bonds among its atoms. That's why it has highest melting and boiling point due to covalent network among its atoms, and this decreases up to gallium, but melting point increases slightly in the lower members. They are indium and thallium. That's the lower member possess strong metallic bonding. That's why they have high melting and boiling point as compared to indium and as compared to gallium. Then which member of boron family has highest electronegativity? This is question number 7. Which member has highest electronegativity? Answer is boron. It is due to small size of boron. It has highest electronegativity, and when it forms the covalent bond, the boron acquires the negative charge, and other element they acquire some but positive charge. What type of compounds are formed by boron family? Boron prefers to form covalent compound due to its small size. Aluminium can form both covalent as well as ionic compounds, while the lower member they prefer to form ionic compounds due to their large sizes. So what kind of compounds are formed by boron family? So boron forms covalent compounds. Aluminium form both covalent and ionic, while gallium, indium and thallium, due to their large sizes, prefer to give ionic compounds. This is our question number 8. Then we come to the question number 9. Comment upon the properties of boron family. Comment upon hydrides of boron family. All the members of boron family, they prefer to form trivalent hydrides. The hydrides of boron are called as boranes. They are BH3, B2S6, B3H8, B4H10, B5H12, B6H14. Boron trihydride, this is diborane, this is triborane, tetraborane, pentaborane and hexaborane. These are the compounds of boron with hydrogen. They are called as boranes. While those the hydrides of aluminium, indium, gallium and thallium, they form polymeric hydrides. Aluminium, indium, gallium and thallium prefer to give polymeric hydrides. They are ALH3X, GAH3X, INH3X, PLH3X. They form long chains of the hydrides, where hydrogen atom, they tend to stabilize the bridge between the large size central metallic atoms. So these are the hydrides of all these elements. Aluminium form a specific hydride, lithium aluminium hydride, which is used as a reducing agent in our organic and inorganic chemistry. White trihalides of boron, they act as Lewis acids. The trihalides of boron, as we know, they have the deficiency of 2 electrons. They are electron deficient compounds, so they will have the net tendency to accept lone pair of electron from other substances. That's why they act as the Lewis acids.